Voltage may be referred to in a number of different ways. Generally, the term voltage is used to describe the force that drives charge around an electrical circuit. When we speak of a battery having a voltage of 1.5 volts, this is being quite specific about the battery's capacity to drive charge. The term potential difference is used when considering the difference in energy levels between 2 points in a circuit caused by the presence of a voltage source. This is analogous to looking at the difference in pressure between 2 points in a pressurized water system. Finally, there is the term EMF or electromotive force, which is very much a historical term for voltage. Today, this term is generally only used when dealing with the output of electrical generators. However, these are all references to the electrical force voltage and are all measured in volts. The voltage or potential difference between 2 points in a circuit can be identified by an arrow or a reference term. If an arrow is used, it will always point to the most positive terminal. So in the first diagram, the arrow is pointing to the terminal A, and in the second, the arrow is pointing to the terminal Y. If the terminals are labeled, the labels can be used as suffixes to reference the voltage. The most positive terminal is always listed first. So in the first diagram, the voltage is termed V subscript AB, while in the second, the voltage is termed V subscript YX. The following example is in the accompanying workbook, Basic Units, Energy, Voltage, and Potential Arrows. In this example, we are required to draw on the potential arrows and identify the potential differences across each element with the appropriate subscripts. To start with, we only have the voltage across the terminals AD termed V subscript AD. This tells us that the A terminal is more positive than the D terminal, so the potential arrow goes between the two terminals with the arrowhead pointing at the A terminal. From this information, and knowing that current always flows from the positive terminal to the negative terminal, we can sketch on the arrows showing the current direction. Now, taking each element in turn and recognizing that where the current enters the device is the most positive end, we can sketch on all the potential arrows and label the voltages. For element AB, the voltage is V subscript AB with the arrow pointing at the A. For element BC, the voltage is V subscript BC with the arrow pointing at the B. For element AC, the voltage is V subscript AC with the arrow pointing at the A. And for element CD, the voltage is V subscript CD with the arrow pointing at the C. Being able to accurately position the potential arrows and understanding the significance of the order of the voltage subscript notation is essential when using many of the electrical network theorems.